Today is February 4th, 2022. My name is Ray H Kenyon. I'm 70 years old. I'm an independent researcher. The purpose of this recording is to explain to you what gravity is and what gravity is not. In order to do that, I'm going to have to take you through a couple of steps. Now, this is a regular bathroom scale, spring-loaded, and when we stand on it, we get a number. In this case, 174. However, if when you're standing on it, you scrunch yourself into a ball, tuck your arms all around you, and look at it, you'll see that you lose 1.5 pounds. I'll explain how that happens later. The next thing is I want to talk about materials with specific gravity. This is water. This is a little ball. I put the ball in here, and it displaces some of the water to come out. And, you know, this is known. This is specific gravity. Here's one, same size, but it's full of water, and a lot more water comes out. So, specific gravity, that's understood. Now, we live on a planet, and we have an atmosphere around us. However, at the surface of the Earth, the pressure is 14.5 pounds per square inch. But if you go up on a mountain, big mountain, the pressure is only 10 pounds per square inch. Higher up you go, the less pressure. Why? Because in space, there's an enormous number of particles in the space. And if you think about an area of space where there's nothing but itself, and then you interject a planet into that area, that planet is pushing on that space that you just moved into. Well, space is pushing back. And like water, specific gravity, you know, when the Earth pushes on the open space, which is full of particles, the particles push back. So those particles are what's basically holding the atmosphere, the water environment on this planet. Now, everything has a resonant frequency. Every material, everything. Space has a resonant frequency. The atmosphere has a resonant frequency. And a couple of years back, my next door neighbor was making a lot of noise on some machine he was always running over there. And it was very noisy, and I got tired of listening to it. So I took a regular tape recorder, and I took the motor out of it so, you know, I could get the electronic results. And I hooked up a speaker and a microphone. The speaker I put way up in the corner of the house, on the corner outside, and then the microphone I put down low, and I adjusted the volume so that the sound that was coming to my house was instantly being pushed back towards its source. And that cut it out. It just, when you have a sound coming one way and you take the exact same sound and push it the other way, they cut out each other. So, you know, and that, I put size C batteries in it. It would last for months. And then when the batteries went down, I just put more batteries in, and I had it up there for a couple of years. It worked great. Now, this is, you know, one of these magic ears. You point and you get a sound. And before I started this recording, I aimed this up here, and I made a recording. And this is simply an amplifier. This is a scale. So if I take this, play this recording of this environment, Yeah, I don't know if you can see this on the video or not. While that's playing, the scale goes down because the sound coming out of these two sets of speakers is pushing back on the sound that's coming in. Okay? So gravity has nothing to do with one planet to the other. It just happens to do with the individual planet. Now, if we change this to the sun, so we have the sun. It has a radiated frequency. It's vibrating. Now, if you've ever seen a recording of a frog on a lily pad and he's making his love call, that continuous noise, you'll see waves being produced in the water around him. But the waves don't go out. They stay in a fixed location in accordance to the frequency that he's broadcasting. Well, the sun is the same thing. It's broadcasting a frequency. And on a two-dimensional scale, that frequency would look something like this. But it's actually a three-dimensional wave, so it actually looks like this. And there's another part of this 3 dimensions that's wrapping around each one. So it's 3 dimensions. The sun, continuously making this vibration, creates a tube around the sun that traps the planets in place, say Mercury, Venus, Earth, Mars, Jupiter, Saturn, and so on. Now, we also know that this is the direction we're heading, south, and the elliptic plane goes up. In other words, the frequency wave moving through space is actually bent up, and the planets are in a fixed position on this. There's no gravity that goes out that influences one planet or the other. Okay? The planets are individual, except for the fact that they are the same thing as magnets. So, you got Mercury, Venus, Earth, Mars, meteorite belt. Think of them as magnets. Now, if you took magnets and put them on a piece of paper and then put a lot of the filings on there, you'd see that, of course, they create, show where the magnets are, where the magnetism is. But the other thing that occurs is that between the sun and the planet, there is a static electrical field created by each. The sun is a magnet, the planet is a magnet, so there's an electrical field created, a static electricity field created. So when a planet is in orbit, like Saturn, Uranus, when Uranus was known and we tracked its orbit, we noticed at some point it started to slow down, indicating that there was another planet influencing it, pulling on it, pushing on it. And that's how we found Neptune. And so from Neptune we found Pluto, the same way. And it was said that the gravitational fields between the planets were having an effect on each other. Well, gravity is unique to the planet. However, the electrical field, the static field, is not unique. Now, in this alignment, this happens very rarely, because you got, one planet here, one planet here, one planet here. But to the sun is a static field. As far as I understand, NASA and somebody has made recordings, pictures of this static field between the planets, saying that we're all connected. And we are in that electrical field, but not gravity. Gravity is unique to each planet. The bigger the planet, the more gravity. Also, depending on where we are in space, the density of space, uh, then you could have a greater and lesser effect. Now, when you talk about the moon, our moon, okay, planet Earth, the moon, each has a static electrical field, and that's the influence of the, because where the planet location is in the vibrational wave created by the Earth, it's tidal locked in the location, in the distance, and the static field to the Earth keeps moving as the moon goes around, and so it's an electrical field pulling on salt water, which is, you know, it's very easy to move using magnetism or electricity, because salt is a great conductor of electricity. So, you have 2 points. One is, let's talk about the scale. When I first stepped on the scale, I got a number. But when I tucked myself up into a ball, I had a lesser number. It was a pound and a half later, lesser. And the reason for that is when I tuck myself up into a ball on that, I'm closing off, I'm blocking off the surfaces on my body. In other words, my knees come up against the chest, that's blocked off. My legs are together, that's blocked off. My arms are wrapped around me, inside of that is blocked off. So by tucking myself into a ball, I'm reducing my surface area. Therefore, the atmosphere has less to push on, and if it has less to push on, you're going to be lighter. Now, I've been told that on a second floor apartment with a flat roof, you lose 2.5 pounds. And that's because of the influence of the push of the atmosphere, what we call gravity, on the building. It's different where the building we're in here, we have a peak. So as the atmosphere pushes, the peak is pushing away some of that influence. Where if you have a flat bottom, flat roof, all the pressure possible is coming right through the roof and pushing on the people and everything in it. So, gravity is a result of space pushing on our atmosphere pushing on us. But the planets in circulation around the sun